Okay, so the example that we were doing in class when we ran out of time was a ball that was kicked at an angle of 53.13 degrees with the ground, and it lands on the roof of a building that's 3 meters high and that's 30 meters away. And it wants to know with what initial velocity was it kicked. So in the x direction, we know we have a VIx, which is VI cos theta. We know we have an AX, which is 0. And we know we have a delta dx, which is 30 meters. And there's a time, but of course we don't know it, and we don't know the VI. In the y direction, VIY is VI sine theta. AY is 9.81 meters per second squared, and this is up, and this is down. And we know delta dy is 6 meters, and it's also up. So you can't find the half time, because, well, you could, but it's of no use because it doesn't land on the roof at half the time, like the time up or the double time. So we can get an equation in our y direction. Delta dy is equal to VIY delta t plus 1/2 AY delta t squared. And this is how, when it's non-ground to ground, we've been finding our time, but this time, this is going to be sine theta delta t. This time, there's two unknowns in here. We don't know the time, and we don't know, that's not really a y. We don't know the VI, so we have two unknowns. So we need to go over here to get our second equation, so that we have two unknowns and two equations. So this second term goes to 0. And so we have delta dx is equal to VI cos theta delta t. So two equations, two unknowns. So you're going to rearrange one and sub it into the other. I would highly recommend rearranging the delta dx because it's shorter and subbing it into the delta dy, and I would rearrange for VI so you only have to sub it in one spot. So VI is going to equal delta dx over cos theta delta t. Okay, and then we're going to take that and sub it in over here. So we'll have delta dy is equal to delta dx over cos theta delta t times sine theta delta t plus 1/2 AY delta t squared. Now, this is not going to be a quadratic because, look, this delta t and this delta t cancels out. So you have delta dy is equal to delta dx, and sine over cos, I'm hoping you remember from grade 11, is tan, right? Because sine theta is opposite over hypotenuse, and cos theta is adjacent over hypotenuse. So when you divide them, it's the same as flipping and multiplying the bottom one. So opposite over hypotenuse multiplied by hypotenuse over adjacent. The hypotenuse cancel, and you're left with opposite over adjacent, which is tan. So sine over cos is tan, plus 1/2 AY delta t squared. You now only have one unknown. It's the delta t squared. So first get the term with that unknown by itself. So delta dy minus delta dx tan theta equals 1/2 AY delta t squared. Multiply both sides by 2, divide by AY. So t squared will be equal to 2 brackets delta dy minus delta dx tan theta. Close the bracket, divide by AY. And now you can sub your numbers in. So 2, delta dy was 6 meters, and it's up, so it's positive, minus delta dx was 30 meters, tan of 53.13, close the bracket, divided by AY goes in as negative 9.81 meters per second squared. So when you do this, the top's going to be negative. I think you get something like negative 67.9 something, keep all the units, meters. And on the bottom, of course, it's negative 9.81 meters per second squared. the meters are going to cancel. You're going to end up with seconds squared. Before you take the square root, it is 6.931672. Take the square root and get a delta t of 2.6328 seconds. Once you have that, the question asks for VI. So now go back over here to this equation and find your VI, right? Remember, system of two equations, solve for one, fill it into the other. So delta VI will be equal to delta dx, which was 30 meters, times the cos of 53.13, times the time you just found, 2.6328 seconds. Okay, and when you do this, you should get a VI of 18.9911 meters per second. All right, so it's kind of cool because of the tan theta and the way the time cancels out and it doesn't end up with a quadratic. All right, so not to fear, I will give you a couple more of these to practice, and including one for homework tonight.